Good morning, students. Welcome to P.N.AMERSEY e-learning classes. Students, today we are going to start part 4 of chapter number 6, Combustion and Flame. So children, let's start this video with the topic flame. Observe an LPG flame. Can you tell the color of the flame? Yes, the color of the flame is blue. What is the color of candle flame? The color of candle flame is yellow. Kerosene lamp, that is also yellow. And Bunsen burner, the color of the Bunsen burner flame is blue. Recall your experience of burning a magnesium ribbon. We find that the magnesium ribbon burns by producing a brilliant white flame. Now children, burn the materials shown in the table 6.2 and record your observations and mention whether on burning the material form a flame or not. It means table 6.2 is given in your textbook page number 70. So in this table some materials are given. You have to burn that materials and you have to tell that they form a flame or not. First one is candle. If you burn a candle, it forms a flame. Magnesium, it also forms a flame. Camphor, camphor means kapoor, it also forms a flame. Kerosene stove, that also forms a flame. Charcoal, charcoal does not form a flame, it only glow. Students, we will discuss about structure of flame. This is very important topic. You have to listen to me very carefully. A flame consists of 3 zones or 3 parts. These are innermost zone, middle zone and outer zone. The 3 zones of flame have different colors and different temperature. We will now describe these 3 zones of a flame in detail by taking the example of candle flame. The first zone is the innermost zone. The innermost zone of a flame is dark or black. The innermost zone of a flame consists of hot unburned vapors of the combustible material, say wax vapors. The innermost zone is the least hot part of the flame. In other words, we can also say that the innermost zone or the dark zone is the coldest part of the flame. Now our second zone is the middle zone. The middle zone of a flame is yellow. It is bright and luminous. The fuel vapors burn partially in the middle zone because there is not enough air for burning in this zone. The partial or incomplete burning of fuel in the middle zone produces carbon particles. These carbon particles become white hot and emit light. So it is the glow of hot carbon particles which make the middle zone of a flame luminous or light giving. These carbon particles then leave the flame as smoke and soot. The middle zone or luminous zone of a flame produces a moderate temperature. This zone is the major part of a candle flame. Now the third zone is the outer zone. The outer zone of a flame is blue. It is non-luminous, which does not produce much light. In the outer zone of a flame, complete combustion of the fuel takes place because there is plenty of air around it. The outermost zone or non-luminous zone has the highest temperature in the flame. In the other words, the outermost zone or non-luminous zone is the hottest part of the flame. The outermost zone of a flame is quite thin as compared to the middle zone. Friends, now we will perform activity 5 to show that the innermost zone of a candle flame consists of unburned wax vapors. Light a candle. Caution should be taken that your hand should not burn. Hold a glass tube with a pair of tongues and introduce its one end in the dark zone of a non-flickering candle flame. Bring a lighted matchstick near the other end of the glass tube. Do you see a flame? If so, what is it that produces a flame? Notice that the wax near the heated wick melt quickly. After performing activity 5, we will observe that yes, a flame is seen at the other end of glass tube. This can be explained as the innermost zone or the dark zone of candle flame near the heated wick consists of unburnt wax vapors. Some of these wax vapors enter the glass tube and come out from its other end. When we bring a lighted matchstick near its end of glass tube, the wax vapors coming out of it start burning, producing a flame. This activity shows that innermost zone of a candle flame consists of unburnt wax vapors. So students, by performing activity 5, we conclude that the substances which vaporize during burning give flames. It means only those solid and liquid fuels which vaporize on being heated burn with a flame. In other words, only those solid and liquid fuels which form gases on being heated burn with a flame. LPG and biogas are gases which undergo combustion. So LPG and biogas burn by producing a flame. Wax and camphor are solid substances. Camphor means kapoor, which vaporizes or forms gases on heating. So wax and camphor burn with a flame. Similarly, kerosene oil and mustard oil are liquids which forms vapors or gases on being heated. So, kerosene oil and mustard oil also burn by producing flame. Kerosene oil and molten wax rises through the wick and are vaporized during burning and form flames. But charcoal is a solid fuel which does not vaporize on heating. So, charcoal does not burn by producing a flame. Charcoal only glows on combustion. Similarly, coal is a solid fuel which does not vaporize on heating. So, coal also does not burn by producing a flame. Coal just glow red on combustion. Now students, we will perform activity 6 to show that the middle zone of candle flame consists of unburned carbon particles. For that, light a candle. Hold a clean glass plate with the help of a pair of tongues and introduce it in the middle zone or luminous zone of the candle flame. Hold the glass plate in this position for about 10 seconds. Then remove the glass plate from candle flame and observe it carefully. After performing activity 6, we will observe that a blackish ring is formed on the glass plate. This blackish ring is produced due to the deposition of unburned carbon particles present in the luminous zone of the candle flame. This activity shows that the partial combustion of wax vapors in the middle zone produces unburned carbon particles. Now students, we will perform activity 7 to show that the outermost zone, that is non-luminous zone of a flame, is the hottest. Take a long copper wire and hold its one end with a pair of tongues. Introduce the other end of copper wire just inside a burning candle flame so that it is in the outermost zone, that is non-luminous zone of flame. Keep the copper wire in this position for about 30 seconds. After performing activity 7, we will observe that the part of copper wire which is in the outermost zone of the flame becomes red hot. This tells us that the outermost zone, that is non-luminous zone of a flame, has a highest temperature. In other words, the non-luminous zone or the outermost zone of a flame is the hottest part of a flame. Now students, this is the answer to the question that which zone of a flame does a goldsmith use for melting gold and silver and why? Goldsmith blow the outermost zone of a flame with a metallic blowpipe for melting gold and silver. A kerosene oil lamp produces a flame exactly similar to the candle flame, consisting of the three zones. Goldsmith blow air with a blowpipe to intensify a kerosene lamp flame for melting and molding a piece of gold and silver into desired shape to make jewelry. When air is blown through a blowpipe into the flame, it helps in the combustion of unburned fuel and hence make the flame hotter. Friends, we will start this video with the topic, what is a fuel? A material which is burned to produce heat is called a fuel. Recall that the sources of heat energy for domestic and industrial purposes are mainly wood, charcoal, petrol, kerosene, etc. These substances are called fuels. So we can say that a material which is burned to produce heat is called a fuel. Now, what is a good fuel? A good fuel is one which is readily available. It is cheap. It burns easily in air at a moderate rate. It produces a large amount of heat. It does not leave behind any undesirable substances. There is probably no fuel that could be considered as an ideal fuel. We should look for a fuel which fulfills most of the requirements for a particular use. Now our next topic is fuel efficiency. Suppose you were asked to boil a given quantity of water using cow dung, coal and LPG as fuel. Which fuel would you prefer? Give your reason. You may take the help of your parents. We will prefer to use fuels which produce more heat, and here LPG will produce more heat. So we will prefer to use LPG as a fuel. Do these three fuels produce the same amount of heat? No. The fuels, however, do not produce the same amount of heat. Different fuels produce different amounts of heat on burning. Some fuels produce more heat, whereas other fuels produce less heat. The efficiency of a fuel is expressed in terms of its calorific value. The amount of heat produced by the complete burning or complete combustion of 1 kilogram of a fuel is called its calorific value. The calorific value of a fuel is expressed in the unit of kilojoules per kilogram, which is written in short form as kJ per kg. Students, table 6.4 is given in your textbook page number 73, in which calorific values of different fuels are given. Fuel like cow dung cake, calorific value of cow dung cake is 6000 to 8000 kilojoule per kg. Wood, calorific value of wood is 17,000 to 22,000 kilojoule per kg. Coal, that is 25,000 to 33,000 kilojoule per kg. Petrol is 45,000 kilojoule per kg. Kerosene also 45,000 kilojoule per kg. Diesel also 45,000 kilojoule per kg. Methane is 50,000 kilojoule per kg. CNG is also 50,000 kilojoule per kg. LPG is 55,000 kilojoule per kg. Biogas is 35,000 to 40,000 kilojoule per kg. And hydrogen is 1,50,000 kilojoule per kg. From the above table, we can see that calorific value of LPG is 55,000 kilojoule per kg. By saying that the calorific value of LPG is 55,000 kilojoule per kg, we mean that if 1 kilogram of LPG is burned completely, then it will produce 55,000 kilojoule of heat energy. The calorific value of LPG is much higher than the calorific value of cow dung cake and coal. This means that the burning of the given amount of LPG will produce much more heat than burning the same amount of cow dung cake or coal. Now our next topic is burning of fuels leads to harmful products. The burning of fuels produces harmful products which pollute the air around us. So the increasing use of fuels has harmful effects on the environment. The important harmful effects produced by the burning of fuels are as follows. First one is the burning of fuels like wood, coal and petroleum products like kerosene, petrol, diesel, etc. releases unburned carbon particles in the air. These fine carbon particles are dangerous pollutants which can cause respiratory disease such as asthma. Second one is incomplete combustion of fuels due to insufficient air produce a very poisonous gas called carbon monoxide. Excessive inhale of carbon monoxide gas can kill a person. We should never sleep in a room with closed doors and windows and having a coal fire burning inside. This is because when coal burns in an insufficient supply of air in the room due to closed doors and windows, then a lot of carbon monoxide gas is produced. When the person sleeping in this room breathe in poisonous carbon monoxide gas, they may all die. Third harmful product of burning of fuels is burning of fuels releases carbon dioxide into air in the environment. Increased percentage of carbon dioxide in air is causing global warming. Now fourth one is burning of coal, petrol and diesel produces sulfur dioxide gas which goes into the air. Sulfur dioxide is an extremely suffocating and corrosive gas. It may damage our lungs. The burning of petrol and diesel in the engine of vehicles also release nitrogen oxide into the air. Sulfur dioxide and nitrogen oxides produced by the burning of fuels dissolved in rainwater and form acids. The rainwater containing acids is called acid rain. Acid rain is very harmful for forest, aquatic animals and buildings. Now students, we are going to learn about deforestation and global warming. Wood has been used as a domestic and industrial fuel for centuries. In many rural parts of our country, people still use wood as a fuel due to its low cost and easy availability. The burning of wood as a fuel has, however, many disadvantages. Some of the disadvantages of burning wood as a fuel are: the burning of wood produces a lot of smoke, which is very harmful for human beings. Smoke causes respiratory diseases. Trees provide us with many useful substances. When trees are cut down to obtain wood for use as fuel, then all the useful substances which can be obtained from trees are lost. The cutting down of trees to obtain fuel would lead to deforestation, which is very harmful for the environment. The use of petrol and diesel as fuel in automobiles, means vehicles, is being replaced by CNG. CNG means compressed natural gas. This is because when CNG burns, it produces very small amount of harmful products. CNG is a clean fuel because it burns without producing smoke. Since the burning of CNG produces much less harmful products and smoke, therefore the use of CNG as fuel in automobiles has reduced air pollution in our cities. Children, listen to me very carefully that what is global warming. Global warming is the rise in temperature of Earth's atmosphere caused by the excessive amount of carbon dioxide in the air. Due to rise in the temperature of atmosphere, the ice in polar regions will melt very fast, producing a lot of water. This water may cause a rise in the sea level, leading to floods in coastal areas. The low-lying coastal areas may be completely submerged underwater, leading to the loss of life and property. So students, this is the end of chapter number 6, Combustion and Flame. Question and answer of chapter number 6 will be given to you in a PDF form tomorrow. Up till then, thank you and have a nice day.